sometimes we're given a scenario where we want to write an equation to represent the scenario so we can make future predictions. If we're given minimal information, because we'll talk about what happens when we're given more information later on, we might use the slope formula to help us out in writing our equation. And then we can write the equation in slope-intercept form, y equals mx plus b. Well, slope-intercept form is good when you know the slope and you know the y-intercept. We don't always know the y-intercept, but it's usually pretty easy to find because if you know the slope and you know a point on the line, you can plug in or substitute the point on the line in for x and y. But this isn't the only way of doing it. It turns out there is a different form of an equation of a line that actually comes from the slope formula. Remember, this was called slope-intercept form. Sorry, my handwriting's getting a little sloppy here. The slope formula is really just a proportion. And how does one solve proportions? Well, you cross multiply, right? If I cross multiply, I end up with y2 minus y1, because that's what y2 minus y1 times 1 is equal to m times x2 minus x1. This formula has a special name. It's called point-slope form. I can tell you in calculus, you often want to write your linear equations in point-slope form because it is the fastest way to write your equation. Another form that we write our equations in, but we don't normally start with this form, this would be one we would derive at the very end of the problem, was our standard form that I talked about in another section. Sometimes it's called general form. It just kind of depends on what resource you're using. Let's do an application problem of writing a linear equation from an application problem. In 1998, the average weekly first quarter sales at Vic's hardware store were $9,250. In 1999, the average weekly first quarter sales were $10,100. Assuming a linear relationship, find the average quarterly rate of increase and an equation which models the situation. So, like we talked about in the last section, you probably want to start with the information and writing ordered pairs. Because in order to write the linear equation, we want to find the slope or average rate of change. And we're going to do that using two ordered pairs that we've told you lie on the line. So one of the ordered pairs is 1998, 9250. I mentioned in the last video, if you needed to watch that, that years normally go in the x-coordinate in the ordered pair. The other ordered pair would be 1999, 10,100. All right, now that we know two ordered pairs that lie on the line, we're going to find the average rate of increase. We know that it's increasing because it was lower in 1998 than it was in 1999, so the value is going up. So let's go and find the average rate of change using the slope formula. So I'm going to do, here's y2 minus y1 over x2 minus x1. Now this is only over a year, so I really only care about what's happening in the numerator. And when I subtract, I get 850. So what that slope is telling us about the problem is that there is an $800.50 increase each year. That's what the rate of change means. Okay, well now I know M. What I need to find now is B. Now you have two options for writing the equation. You can use slope-intercept form or you can use point-slope form. I'm actually not particular about which one you want to use. I'm going to tell you this one requires less work. If you know the slope and you know an ordered pair on the line, you can just plug it into point slope form. So maybe I'll use the first order pair. So y minus 9250 is equal to, what did I say m was? 850. X minus 1998. There's actually another way of doing this. A lot of times when we deal with problems involving time, or years, I should say, instead of actually using the year, we'll convert it to years since some other year, usually whatever the first year they give me. So I could have instead called this 0 and this 1, and I would have gotten the same slope. The only difference is my slope-intercept form would have been a little different because this would have said 0 instead of 1, or instead of 1998. But it really doesn't matter for this particular problem. This is an equation that represents the situation. And that's really all you need to come out of Section 1.4, writing linear equations.